All right. So 1 minute in, let's actually get this show on the road. So I just want to say welcome everybody to our webinar. We'd love to talk to you today about a few things. I am Derek Abdine. I'm CTO at Censys, and we have
Zack Hardie, an R&D engineer here at Censys.
And we just are excited to talk to you about some of these risks that we see common on the internet and what you can really do about them to secure your surface area. So without further ado, let's roll into it. Let's get started. So before we really go back into risks and just dive in, I think it's important to really set some context about the internet in general, about why we're all here today, what brought us here, and what was the history that brought us here. So to do that, let's actually go back a little while. Let's go back 20 years to the beginning of the 2000s. And let's talk about what happened in that earlier time. In the 2000s, well, you know, that was the kind of blossoming era of the internet. If you remember, high-speed internet was just becoming available to to households. Households were on dial-up otherwise, and folks were starting to see that they can do commerce on the internet, which was exciting. These were the earlier days of course, Amazon, which started in '95, but was starting to become a bigger deal then. And this was also an era where the internet and tech companies in general were going through this bubble phase. So there were a lot of companies that didn't make it in that era, but there's this rapid expansion of IT. And during that time, if you'll remember as well, there were a ton of other things that were happening within IT. Well, you know, for the first part, VMware in 1998 was a new company, and we didn't really have virtualization. But by 2002, 2003, we started to see one of the first ESX hypervisors that were available on the market. Virtualization was still in its infancy, but by and large, we all actually went out and went to go rack servers. We didn't use a lot of virtualization. We didn't use a lot of clouds. So that was just something that we were starting to get into. IPv4 address space, as we all know, we'll get into where that is now, which I'm sure you may be aware of, but back in the 2000 era, there were roughly 2 billion IPv4 addresses that were unallocated. So if you look at the growth, which we'll get into in a second as well, the growth of the internet from 2000 to today has been astronomical. And most of us, again, we just racked servers. We relied on static IT. We got net blocks from you know, from major registrars, and we just assigned them, and we did our own routing. Everything was done by hand. And in some cases, a lot of us actually went out and put servers in our own offices to host the services that we needed to actually provide service back to our customer base. So it's a world of manual interaction. It's a world of, you know, slow churn on IT. It's a world of mostly static processes, things that didn't change a lot. So from an internet perspective, you know, lots of things that were just kind of slow and steady, and the churn rate was very low. But by the mid-2000s, something interesting started to happen. By 2006, we saw the advent of AWS. And we all know AWS is this large cloud service provider, and a lot of us probably use it. But AWS started to flip the script a little bit on IT. We went from this concept of manual deployment of IT infrastructure and lots of hands-on data center and coordination activity to this concept of, well, maybe you didn't need that. Maybe you could use an API to drive new infrastructure. And so that was a radical shift in thinking. I remember one day, actually, a friend of mine came to me excitedly saying, and showing me two graphs, one which is a staircase up and to the right, and one which was a linear, just a straight line up and to the right. And they're saying, look what the cloud's gonna do. We don't have to buy these big, massive stacks of servers anymore. We can just go use a cloud and linearly scale. And I think everybody thought that idea was kind of interesting, and was cloud really gonna take off back then? But we know now that it absolutely did. If you remember around 2007, so just a year later after AWS came out, we had the first iPhone was on the market. And this was starting to move computing from the desktop back into our pockets. By 2008, the first Android phone came out, the T-Mobile G1, also known as the HTC Dream. And this was the first release of an Android OS on a mobile platform. Pretty amazing shift to this, again, in-pocket computing era, where now more things are connected to the internet, more things are using more bandwidth, and there's this hunger for folks to interact with services that are available. So, you know, by the time we're at this state, the internet's getting more chatty. There's many more devices that are starting to exist. IoT is starting to come online slowly and slowly. And IoT, if you kind of look at that, you know, internet connected devices were really based on computers, because developing, you know, internet or stacks of networking stacks for devices that you deploy, that was not very cost effective, but the costs have been driven down. So you're starting to see things come online that you would have never imagined would be connected to any kind of network, let alone the internet. By 2010 alone, 770 million roughly IP addresses that were unallocated. So we went from 2 billion in 2000 to 770 million. That's an amazing growth rate and it speaks volumes about how our society has grown globally on internet usage. But today, the cloud has shifted and expanded much more. So if you look at just alone in 2019, 37.3% of growth for cloud was made. Now, on top of that, 80% of that growth was from AWS, Azure, GCP, Alibaba, Tencent, the major cloud providers. So this is a phenomenal growth rate that, again, it implies that we're all adopting cloud environments, and these cloud environments have introduced unique risks to us. But if that wasn't enough of an issue to figure out in how we manage security and our security posture when it comes to dynamic IT, one of the other things that came up most recently this year was the pandemic that hit, and it's affected pretty much everybody. And we found ourselves, before utilizing the cloud, to go from this, you know, we want to be able to bring online systems fast to rapidly respond to customer demands as the main motivator for cloud use. And then we've all found ourselves working from home. And that was another motivator for us to start looking externally, you know, racking servers and maintaining IT within different data centers becomes more of a problem. Finding centralized ways for folks to access resources behind the LAN, that's more of a problem because of VPN issues and saturation of VPN links and so on. So it caused an immediate radical shift that we've all been living with since the pandemic hit, that we've needed to find solutions to. But let's go back for a second. As I was just talking about, before the pandemic, we're just trying to figure out, how do we get fast? How do we move from that static model that we had in the early 2000s to something that's more dynamic and really meets the needs of how we're trying to expand and grow quickly? So we had corporate cards, you know, the corporate card that I'm sure a lot of folks have. This is not an endorsement for any specific company, but the corporate card allowed us to just swipe a card and get new infrastructure online quickly. And that's fascinating, because what happened was, and what's still happening is, this idea of digital dexterity or citizen IT, where people are now just embracing the concept of decentralizing these decision-making around when IT and who creates new infrastructure. And that infrastructure is now available for anyone in your company to go swipe a credit card and get an AWS account online. Go swipe a credit card and get a Salesforce account, a Salesforce SaaS license, for example. And so I think if you look at those types of issues, you find that, you know, folks are finding shadow IT just from other folks in their organization trying to deal with developing new services. They're finding shadow IT with finding, you know, dealing with new licenses that other groups are creating. Maybe your marketing group and sales group also both bought a license for some SaaS products. And you just need to get a handle on all of these things and identify where that brings risk back to your organization, and ultimately, how do you deal with that risk? So without further ado, we're going to step right into some of those. I'm going to hand it over to Zach and talk about 3 of the most interesting risks that we see. Zach, take it away.
Thanks, Derek. So the first risk that we'll be talking about is most vendors publish notices when they sunset software. Microsoft does this for Windows, Oracle does this for databases, and so on. After software is obsolete, it is common that no new updates, including security fixes, will be pushed out. So if a new issue arises, you can't always count on patching to solve the problem. It's always best to get ahead of obsolete software before it becomes an issue. Most vendors publish when their software will become obsolete way in advance to make this an easy problem to manage. Despite how obsolete these services are, there is still a significant number of people using them, and they're still very much targeted. For instance, Windows XP came out in 2001. It was put to rest in 2014 when Microsoft dropped all support, including security patches. However, 5 years later, they released a patch for XP. It's only under extreme circumstances that a patch like this is released so far after being deemed obsolete, which speaks to how severe this security flaw is. As of last year, according to net market share, over 3.5% of all desktops and laptops still run Windows XP. That's not a huge percentage, but it's still a ton of devices in the grand scheme of things. Even though a patch exists for this critical vulnerability, it's a terrible idea to rely on developers supporting sunset software. As another example, let's look at Apache HTTPD, which sent out an end-of-life notice for version 2.2 of Apache web server in 2018. Apache is a critically important component to the web. According to Netcraft, Apache is on 37.3% of all internet-facing computers and serves a third of the top million websites worldwide. And here we are 2 years later with almost 37 million Apache 2.2 servers currently online, according to our own global data set. Let's go further with that Apache example and see if we can find any end-of-life versions running in our own environment using the Censys SaaS platform. Under the Software tab in Section 1, we can filter to show all of our instances of Apache. At a quick glance at Section 2, we can see that we have 2 hosts running that old sunset version 2.2.15. Drilling in further, we can enumerate those hosts that we need to update and shut down. To dig a little deeper, we can also check out the potential CVEs along with their severity score to obtain a better idea of priority on how to triage these issues. Now so obsolete software, what do we do about it? So first step is to discover these obsolete services for your internal attack surface and work on upgrading those servers that have obsolete versions. Then you should identify the owners of these systems to bring those internet exposed devices into your managed security program. And then monitor for critical patch releases and software updates. Although if you can't update or patch because it's legacy software running in an integral service, like an old service, then try to monitor those logs for abnormal behavior like you normally would. Now back to Derek to talk about our second risk.
Thank you, Zach. And yeah, obsolete software is one of those things where it's been out for quite a while. I think we're all aware of it. This has been a practice, I think, for many land-based scanning tools in the past to display. But I think when we look at internet adoption and internet use, there's a greater risk of exposing obsolete software on the internet just because the audience is much larger than it would be within your private network. But there's another risk that we would like to talk to you about today. And I just want to say a side note, hopefully the audio quality is a little bit better now. I'm on a speaker instead of my previous headphones. But when we think about remote administration, I think these are one of the things that I also get really passionate about because there are quite a few, and this is an exhaustive list. So you see here is Telnet, RDP, SMB, and iDRAC. We're going to talk about Telnet in a second, but I actually want to focus more on the RDP, SMB, and iDRAC protocols or administration interfaces that you see here. There are others like VNC and a bunch of others that are out there as well, but these are some of the top that we see that are kind of either ubiquitous or very strange to note that when you see these on the internet, you really want to do something about them. So first off, RDP. RDP stands for Remote Desktop Protocol. This is a protocol that was created by Microsoft quite a while ago that allows administrators to go on and remotely administer a machine so that they can better, service client needs, maybe their own employees, without necessarily having to physically be at the machine. This is a great idea, and this is a great way to actually keep up with the demands of a growing company. However, RDP has some unique challenges. As you may well be aware of, there was a Bluekeep issue that came out around last year, and that was weaponized. That was a remotely exploitable, weaponized issue that created a lot of problems for people and allowed compromise of the systems where RDP was found to be running. The other thing though is let's talk about SMB, because SMB, if you know what that is as well, it's a protocol for doing file sharing. And it was, if you know about the history of SMB in Microsoft, well, a while ago it used to be called CIFS, which is Common Internet File System. You know, it doesn't really matter. Now everyone just calls it SMB. But suffice to say, primarily used for file sharing, but also used for remote administration, because you can make remote procedure calls to it, and admins can actually you know, execute some commands on remote systems with it that allow them to do some administrative action. So, but if you've been paying attention in the news of the last decade or even more, SMB has been a target of lots of wormable vulnerabilities. Just going back as far as 2008, Configure was a big worm that came up back in that era. In Configure, sometimes we actually see that. I know there are some folks that have done research and actually still see signs of Configure trying to spread today. It's just really weird, but you still see those systems out there that maybe just be hanging off. WannaCry, not Petya. So these were events that affected the globe. And it was large ransomware campaigns. And these took advantage of an exploit called Eternal Blue that was leaked out onto the internet. And these had a very severe impact. Suffice to say that SMB is a protocol where even if you don't know vulnerabilities that exist and should be patched, assume that it's vulnerable, because more often than not, you find that there are unknown or zero-day vulnerabilities available for these types of protocols that may not have patches that are out yet. So these are low-hanging fruit for attackers, and I would always recommend just getting rid of them the second you see them. So one of the last things on this list is iDRAC that I wanted to just cover quickly. So iDRAC is a remote administration, hardware administration interface that you typically see on server computers. It's essentially a hardware card that you can pop in the computer. It has essentially an Ethernet port on it. But for whatever reason, you tend to see these on the internet. It's not that great. We don't like to see these. So if you do find any on your network, on your remote exposure, obviously you're not going to see these as much in the cloud. If you do, that's really weird. But if you have anything that's remotely exposed in your own data center, absolutely shut these down, excuse me. Absolutely shut these down immediately, because there's no business for having remote hardware administration interfaces exposed. But let's talk a little bit more about Telnet. I mentioned that one not too long ago. So Telnet alone, there's 2.6 million Telnet services that you can measure on the internet right now, this week, 2.6 million. That's an amazing number, considering the fact that over a period of time, let's say going back to 2007, as far back as 2007, there was a Solaris remote administration bypass vulnerability where you could send some flags, and it was a very simple exploit and get root access to a host. Not to mention that Telnet's an unencrypted protocol, meaning anything you send over the wire, people should be able to sniff and see. So the second you see that protocol, shut it down. Also, I think is a notable mention that credential stuffing is common across a lot of protocols that are exposed to the internet. So that's just when someone gets lists of passwords, maybe from dumps, that some passwords, some database of user accounts is stolen. They'll take those accounts, they'll use the password from those accounts and just shove in all the passwords and try every password they can to get something out of the machine. The last thing I would kind of say is, now if you look at RDP, SMB, and Telnet combined, 7.2 million devices this week we found alone of those exposed to the internet. In Google Cloud, we found 140,000 of that combination. In AWS, 350-ish thousand. And in Azure, 250-ish thousand. So we know that this is still a problem. We know that as we're growing and adopting cloud environments more, and we're starting to provide more connectivity of devices to the internet and to our networks, that finding a way to understand our surface area and deal with these issues is going to be a big deal. So if you can deal with this, how would you kind of approach it? In our SaaS platform, if you were to go to it, you can actually see in the risks section where the top remote administration on the off server category has exposed services. So in this case, you're looking at Telnet. It's marked as a high risk. You can drill into this and actually see which hosts are in that risk, and then you can take further downstream remediation actions. Maybe it's just creating a ticket and using that ticket to drive closing this port on that remotely exposed device. These are exposed on the internet, just to be clear. These aren't within your LAN. You go in here and you immediately see there's just nothing to deploy. So these are exposed to the internet. Go in, you go, you can go remediate that. And I think that's the best action. You can go down, you plug it into your tools, or take care of it manually through your ticketing process. So if you really want to kind of, step back and look at all the different opportunities to mitigate some of these issues, just as explained, one, it starts with just the attack surface posture. What does it look like? The sooner you know what that looks like, the better off you'll be in understanding how to now take action and remediate those issues. And then the second one, of course, is just shutting them down. But that's not always realistic. So let's go over a few ways to deal with these, a little bit more detail. For RDP specifically, you can enable NLA, network level authentication. We do find that a lot of devices tend to have NLA, and that's great. But there are still some that don't. And it just takes one RDP service that's exposed to the internet that does not have NLA on it that may allow you to be compromised. So look at that mitigation, and it's just essentially a configuration option for the host. Second, if you really need to do file sharing, consider maybe moving to a SaaS platform that allows this. So for example, a bucket and a major cloud provider, a file sharing service. If you need encrypted file sharing, something like a Kiteworks might be a good solution. But really take a look at where your data is going and whether you need protocols like SMB, which I would say are more on the legacy side, or if you can use something more robust, more resilient, and that offloads the risk, that the protocol version, the network stack version of the risk to another provider, and you can control the data from your policy and governance perspectives. The next thing I would say is if you can't do any of these things, then I would also recommend whitelisting. It's not the best solution because, if you probably have done this before, you'll know that maybe you changed ISPs at your office. Maybe you move an office ISP, and it becomes hard to just track what's whitelisted, what IP addresses are whitelisted, and constantly obtaining and gardening the whitelist. But I would say if you can, then try to do that. Try to allow IP whitelisting, and try to restrict which IP addresses can access those services, so that you don't have further exposure than you need to. And then lastly, if you can't do any of those things either, maybe you consider, instead of putting these things directly on the internet, that you put it behind a VPN concentrator. The downside of that is that it works well for things like remote administration, remote desktoping activities like RDP. Doesn't really work well for SMB unless you have a very fat pipe for bandwidth. And this is the reason why, is because if you have lots of users that need to send and transfer lots of data over your VPN concentrator, you're going to saturate that link really quickly. So it's not something we commonly recommend. But if it's an option on the table, might as well consider it. So with that being said, I'd like to toss this back over to Zach, who's going to tell us a little bit more about domain risks. Zach, take it away.
Thanks, Derek. I do find it kind of fascinating just how such an ancient protocol like Telnet has ended up in cloud, so many cloud hosts. Just very strange to me.
I know, 1969 it's been out. That's insane amount of time.
Yeah. Well, looking at our third risk, I'd like to talk a little bit about domains and the dangers in letting them expire. Sometimes when testing a new technology or sunsetting a feature or rebranding a business, one can find themselves abandoning a domain and subsequently letting it expire. If domains expire, they're purged from the registry and can be snatched up by anybody else. This can be dangerous to your remaining business functions, though, and pertains to domains currently in use as well as old ones. The new registrants of your abandoned domain can pose as your company and defraud your organization, causing serious harm to your reputation. And any email addresses or accounts associated with that re-registered domain can be intercepted, potentially leaking very sensitive information. This is a really easy problem to forget about, especially if you haven't set up any registration reminders, or if the reminders that were set up by a previous engineer no longer go anywhere actionable. Just a personal story, and the reason why I feel so strongly about domains is once upon a time at my last company, I was in charge of a domain and panicked when I realized that I had accidentally let our test domain lapse. It wasn't a production domain, but I could have broken some of our automated test pipelines. So it was pretty embarrassing that I didn't know when it had expired. But fortunately, Censys can help here with our domain assets tab. So once again, looking at our SaaS platform, in the Domains tab, all of your domains should be listed, along with their registrar and when they're due to expire. You can sort by the expiration to see which ones are coming up, and of course the ones that are past due. In this case, you can see that we have one that expired on August 30th. Perhaps a better way to visualize when these expiration dates are approaching is from our risks tab, where we can find that domain that we previously saw that expired in August in a familiar calendar view. Clicking on that date or any future domain expiration dates will also show any domains in question, so you can tackle those renewals before they expire. So with these expired domains, what do we do about it? How do we tackle this? Well, the easiest and best option is to enable auto renewal if it's possible. It's generally recommended to indefinitely renew domains that your organization has ever touched, even if you don't plan on using it ever again. If all else fails, set up, or your registrar doesn't support auto renewal or anything like that, then set up a recurring reminder to a broad mailing list, perhaps SRE or Ops or whoever's responsible for maintaining those domains, so that you don't end up like me forgetting to renew. And that's about it for our third risk. Back to you, Derek.
Thanks a lot, Zach. And I think we all have our fair share of fun stories. I have one, or two myself, but I think it's probably better for a different webinar, maybe a glass of bourbon or water. So let's actually talk a little bit now about integrations, because I think we mentioned a little bit about this earlier. But Censys does have a lot of pre-existing integrations with Splunk. We have tools like Metasploit that we have integrations with Threat Connect when you're looking at threat intelligence angles. And as a secret to everybody that's on this call right now, on this webinar, we actually will be announcing soon a Tenable integration. So keep your eyes peeled for that. That's going to be exciting. These integrations allow you to pull this data out and really take action on some of these risks that we talked about today. Now, what do we do? Let's recap a little bit. What did we talk about with some of these risks and how you can deal with them? First, we covered obsolete software. Absolutely critical to take care of. Obsolete software has a ton of risks related to it, and finding where you have obsolete software and patching or shutting off those services if you don't need them anymore. Maybe it was spun up by a developer and so on. That's absolutely critical, because these are services that may have vulnerabilities that come out and the vendor may just not patch it for you. So highly recommend taking action there. We also talked about exposed remote administration services. I talked a little bit about statistics around how much of this is exposed on the internet. And I talked about some of the risks around these and some of the kind of zero-day aspects as well, where you have SMB and RDP. Remote administration services really have no usual business of being on the internet. So if you do see them, please go take care of them, find some action, find some mitigation, incorporate them inside your security posture, and create some policies that maybe help managing those and pulling in your shadow IT in some cases as well. The last one we talked about was Zach was covering expired domains and how that may impact your reputation, risk for your organization. This is something I love domains, just to kind of like put that out there. Like I am giddy about domains. Like if you've ever seen some of my past rants in other channels that I've done, it's one of those sayings. It's always DNS. It's absolutely true. Domain names are a source of a lot of growth and excellence for us as we're companies and we grow. They could also be a source of pain if not managed, and domain names aren't managed very effectively. So if you do have these problems, please take a look and go try to see if you can shut them down. The last thing I wanted to say was that whatever avenue you can use to find this information out, to look at your attack surface area. I'll say that Censys Search is an absolutely free product. Go to censys.io/IPv4. It'll go to censys.io and click on the button at the top right that you'll see there. That'll give you right into search, and you can look at your own IP address space and explore what you have exposed. If you'd like a little bit more help than that, we have the Censys SaaS platform. And the Censys SaaS platform is what you saw on the slides today that we demoed and we talked about. And that'll really kind of do the analysis, more of the analysis for you, so you can take care of take care of the issues and take more on the action side than having to do more of the digging. So we're trying to provide that as a solution as well. ultimately, if you have any questions at all, if there's anything that was unclear in the webinar, if you have any feedback, we'd love to hear it. I love getting feedback of all kinds, positive and negative. Please just send it our way. You can reach out to us at hello@censys.io, and you can reach out to us. You can visit our website at www.censys.io as well. But otherwise, that concludes our webinar. Thank you so much for joining, and hope to see you again sometime soon. Take care.